Welcome back to the part 2 of the drawing Lewis dot structure tutorial. In this tutorial we will go over the drawing the Lewis dot structure on atoms that can go more than they have more than 8 electrons, okay, exceeding the octet. Welcome back to the part 2 of the drawing Lewis dot structure tutorial. In this tutorial, I will teach you how to draw Lewis dot structure that an atom could go over 8 electrons. Okay, the atom that can exceed 8 electrons, exceeding the octet for itself. Now, we talked about this in part 1, that for elements that in the third period and below, okay, the elements that is in the third period and below, they are capable of taking more than 8 electrons. Now the reason for this, okay, why is it third period? Okay, people may ask this. Why is it third period and below? Well, if you look at the electron configuration, look at the energy level, look at the orbitals, what you realize in the third energy level and below is that, well, it has the s orbital, okay, it has the p orbitals. Now, with the s orbital and the p orbitals, there are a total of 8 electrons in these two kinds of orbitals. But if you look further, well, in the third energy level, it also has the d orbitals. Okay, the d orbitals can take up to 10 electrons. So this is the reason why the elements in the third period and below, they are capable of taking more than 8 electrons, is because of the existence of the d orbitals. Now for the first energy level and the second energy level, okay, for the first energy level, it has only s orbital. That's why we have only 2 electrons for the hydrogen. In the second energy level, we have the s and the p orbitals, so the maximum is 8. So here we could have more than 8 electrons for elements that are in third period and below. So now we will consider this example, okay? Phosphorus pentafluoride. Now, we'll do the same thing as we have seen in part 1, that we will first calculate the number of valence electrons first. So if you look at the periodic table, phosphorus has 5 valence electrons, and fluorine has 7 valence electrons. So here we have 5 fluorine, and then there are a total of 7 valence electrons. So this is how we calculate the total number of valence electrons in this molecule. So if you do the math, it is going to be 5 plus 35 electrons, and the total is 40. Okay? Now, we will follow the same procedure. Phosphorus, okay? So we have these atoms right here, and phosphorus is capable of taking more bonds. Okay, so we will connect the fluorine to the phosphorus with a single bond. Okay, so now with these covalent bonds, we have used 10 electrons. Okay, so we subtract 10 electrons, so we have a total of 30 remaining. Okay, so now we're going to distribute these 30 electrons onto these 5 fluorine atoms, one by one, to make sure it is octet. For each fluorine right here, they have 2 electrons drawn already because of the single bond. That means each fluorine would only need 6 electrons. So let's do this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Okay, so by filling the electrons to the fluorine atoms to make sure they are octet, we have drawn 30 electrons. Well, that's the total valence electrons that we have left so far. So we have 0 electrons remaining. So now, what do we do with this? Okay, so we check to make sure each atom is octet. Each fluorine is octet. Now look at the phosphorus. If you look at phosphorus, it has 1, 2, 4, 6, 8, 10. 10 total electrons. Is there a problem? Well, for phosphorus, if you look at the periodic table, phosphorus is in the third period. So therefore, it can take more than 8 electrons. And this is the reason why we have this structure. Okay? So let me show you another example. The other example is sulfur hexafluoride. Okay? So here we will do the same thing. We will calculate the number of electrons. So we have 6 electrons from sulfur. Okay? Chlorine has 7 electrons each. So we have 6 times 7 electrons. So if we do the math, we have 48 total electrons. Now let me erase this part here since we have drawn this already. Okay, now we will follow the same procedure, connect the atoms together. In this case, sulfur will be the central atom. So let's just evenly distribute the chlorine atoms like this, and we will join the atoms together. Okay, chlorine with the sulfur, like this. Now by drawing this, we have drawn 2, 4, 6, 8, 10, 12. 12 electrons. So let me do the math on the side here, minus 12. So we have 36 electrons remaining. Now we do the same thing. We will put the valence electrons into the, we'll put these electrons onto the chlorine to make sure they're octets, one by one. 1, 2, 3, 4, 5, 6. Okay, now I'm not going to count it one by one because it's kind of tedious. So if I draw 6 electrons on one single chlorine to make an octet, and we have 1, 2, 3, 4, 5, 6 chlorines total. Well, if you do the math, then we have drawn 36 electrons. Okay, 6 dots per chlorine atom, 6 chlorine atoms total. So we have drawn 36. And we have 0 electrons remaining. So this is the Lewis dot structure for sulfur hexafluoride. Okay, and for sulfur, if you look at sulfur, do the electron count: 2, 4, 6, 8, 10, 12. Okay, so there are a total of 12 electrons, and it is okay for sulfur to have more than 8 electrons because if you look at the periodic table, sulfur is in the 3rd period. So this is how we draw Lewis dot structure for atoms that can go more than 8 electrons, exceeding 8 electrons, not following the octet route. Okay. Now, so you may ask, how do we know? How do we know if it's going to have more than 8 electrons? Well, sometimes it's more by the based on the experience. And the other thing you can look at is if you look at sulfur hexafluoride, okay, being able to connect the 6 chlorine atoms to sulfur, it has to have more than 8 electrons because there are a total of 6 covalent bonds there. Okay, and now just a reminder, the elements in the 3rd period and below, they could have more than 8 electrons, but that doesn't mean they always have to have more than 8 electrons. Some of the molecules that contain elements in the 3rd period and below, they just have 8 electrons. So it has to do with the total number of electrons, valence electrons available, and how many atoms are there. So this is how we draw the Lewis dot structure for atoms that can go over 8 electrons. In the next tutorial, we will go over 2 types of example. Okay, one is what happens if there are electrons remaining that's not drawn on the outside atoms. Okay, the other example is to draw ions. Okay, so we will see you in part 3.